the contradiction means? That means if we start for a journey and we have two paths in front of you, and the first path will lead to your destination, and second path is the wrong path. Okay, but if you travel by the wrong path, that is the second path, at some point you will find some mistakes or something wrong in that journey. Okay, if you find something indifferent or something wrong in that journey, then what we can conclude? Oh, this path is not the correct. Okay, this path won't lead to our destination, so we have to go by our first path. Similar way, if we are going by a path and whether we are checking that is a wrong path, and we are checking that whether we will find something wrong in that path here. If we find something unnatural, then we will conclude our path is wrong. So what is our path here? At first, assume route 2 is rational. If you go by that path, if we get something wrong in that path, we can conclude what? Route 2 is irrational. So we have two ways, okay, two paths. One thing, root 2 is an irrational number, and another thing, root 2 is a rational number. So we are moving by rational path, and we are proving that path is wrong, and which is the correct path? Root 2 is an irrational number. Okay. So for that, what if the root 2 is irrational? Rational, then root 2 equal to p by q, where p and q are integers and q not equal to 0. This every rational number can be represented like p by q. We are representing root 2 as p by q. And another important fact that is we are using for this theorem is that HCF of p and q equal to 1. That is the highest common factor among p and q equal to 1. So that P and Q are coprimes. What do you mean by coprime? Coprime is any two numbers having HCF 1. That is 3 and 4. 3 and 4 has HCF 1. That is no common factors among them. So their HCF, that is highest common factor among them is 1. So 3 and 4 are known as coprimes. One more example about that, 130. Okay. So here P and Q are coprimes. That is least common factor among P and Q is 1. That is, or in other words, there are no common factors among P and Q other than 1. Then, what is next? We are taking Q to the left side. Then, root 2Q equal to P. Then, squaring on both sides, what we will get? 2Q square equal to P square. Okay. So, what we get? P square is a multiple of 2. So what we can conclude? Then 2 divides P square. Okay. If P square is a multiple of 2, then 2 will divide P square. That is, if 6 is a multiple of 2, then 2 can divide 6. Because 6 equal to 2 into 3. So 2 can divide 6. That is, if we divide 6 with 2, we will get a remainder 0. Similarly here, if we divide p square by 2, we will get a remainder 0. So 2 divides p square. Since p square is a multiple of 2. Then by the theorem, what we can conclude? If 2 divides p square, then 2 divides p2. Okay. Therefore, 2 divides p. Then, what is next? If 2 divides p, what we can say as by here? P is a multiple of 2. So, what we can represent as p? If 6 is a multiple of 2, then 6 equal to 2 into 3. Okay. If 14 is a multiple of 2, then 14 equal to 2 into 7. Similarly, if p is a multiple of 2, then p equal to 2 into 6. Or you can do it by our division lemma. That is, if 2 2 divides P, then what will be our quotient is from C, and what is our remainder? 0. That is P equal to 2C plus 0, which can be concluded from 2 divides P. Okay. Then if P equal to 2C, then what is? Then we are applying that result here. Then P square equal to P square equal to 2C whole square. Then 2Q square equal to 4C square. Okay. That is here P square is transformed into 4C square, and now cancelling 2's in their terms, we will get Q square equal to 2C square. What which implies similarly we get Q square equal to 2C square. Then 2 divides Q square, or Q square is a multiple of 2, which implies 2 divides Q. That is a Q is a multiple of 2. Then what we can write? Q equal to some 2K. Okay. Hence, what we got? 2 divides Q and 2 divides P. So what we get? 2 divides Q and 2 divides P. Hence, P and Q have a common factor, which is 2. That is, highest common factor among P and Q is 2 or something greater than 2, not 1. Okay. That is, P and Q has a common factor which is 2. And why? 2 divides P and 2 divides Q. That is, if 2 divides 6 and 2 divides 24, 6 and 24 has a common factor 2. That may be its HCF or something greater than that will be its HCF. Okay, which contradicts the fact that HCF of P and Q equal to 1. So what we assume, our assumption is that only common factor, that is highest among common factor among P and Q is 1. So we get one more common factor is there, that is 2. So our assumption is wrong. That is, what is our assumption? Root 2 is rational. So our assumption is wrong, that root 2 is rational. So what we can conclude? Root 2 is an irrational number. So which is the wrong or something unnatural we find in our path is that HCF of P and Q equal to 1 is according to our definition, but we got something that P and Q has a common factor other than 1, that is 2. Hence, what is our assumption? That is, root 2 is rational is wrong. That we saw that path is wrong, and we have to move by the first part. What is that? Root 2 is irrational. Hence, we can conclude